This tomato was grown in a bucket of dirt. No pump, no air stone, no nutrient reservoir, no pH meter, no timer, no electricity, no daily monitoring. The bucket was filled once, planted once, watered from a tray, and left alone. This tomato was grown in a deep water culture hydroponic system. Air pump, net pots, pH-adjusted nutrient solution, weekly reservoir flushes, daily EC monitoring, and a $500 equipment investment. Both plants are the same variety, same seed batch, same age, same light conditions. The soil plant is 4 inches taller. Its stem is thicker. Its root mass, when pulled, is denser, more branched, and visibly covered in white fungal fuzz that the hydro plant does not have. The hydro plant produced 6 tomatoes. The soil plant produced 9. That is not supposed to happen. Every indoor growing forum, every controlled environment agriculture textbook, every hydroponic retailer tells you that soil cannot match hydro growth rates, that water-based systems deliver nutrients faster, oxygen more consistently, and yields more reliably than any dirt-based method. They are right about the mechanism. They are wrong about the conclusion. Because the mechanism that makes hydroponics fast is not water. It is not pumps. It is not synthetic nutrients. It is constant root zone access to oxygen and dissolved minerals. And biology replicates that access better than any machine, if you build the system correctly. Welcome to the Invincible Method. This is the biological engine, and it is about to make your hydroponics setup obsolete. Let us give hydroponics its due, because understanding why it works is the key to replacing it. A plant's growth rate is governed primarily by 3 factors at the root zone: oxygen availability, nutrient concentration, and water access. In conventional soil, the kind most people use, all 3 are limited by the physical structure of the medium. Standard garden soil or potting mix is dense, pore spaces are small. After watering, those pores fill with water and displace air. The root zone becomes temporarily anaerobic, oxygen-starved until the water drains or evaporates. During that window, root respiration slows. Nutrient uptake stalls, growth pauses. Hydroponics eliminates this bottleneck entirely. The roots sit in oxygenated water. An air pump bubbles oxygen directly into the solution. Nutrients are dissolved at precise concentrations, immediately available in ionic form. The root never waits for anything. Oxygen is constant, nutrients are constant, water is constant. The result is a 200 to 300% increase in growth rate compared to conventional potted soil. That number is real. It is well documented, and it is the entire sales pitch of the hydroponic industry. But here is what the sales pitch leaves out. The reason conventional soil is slow is not because soil is inherently inferior. It is because conventional soil is biologically dead. Bagged potting mix is sterilized. It contains no fungal network, no bacterial community, no protozoa, no nematodes. It is an inert mineral scaffold with some peat and perlite mixed in. The roots are alone in there. No partners, no network, no biological infrastructure. Hydroponics beats dead soil. That is not a revelation. That is a low bar. The question is, can living soil match the mechanism that makes hydroponics fast, constant oxygen, constant nutrients, constant moisture, without the machine? The answer is yes. And the biology does it better. A living soil engine replicates every advantage of hydroponics through 3 biological systems that operate continuously, self-regulate automatically, and cost nothing to maintain. System 1. Constant oxygen through structure. The reason hydro roots get constant oxygen is that they hang in air or in aerated water. The reason conventional soil roots do not is that the pore spaces are too small and collapse when wet. But pore space is not fixed. It is a product of soil architecture, and soil architecture is built by biology. Mycorrhizal fungi produce a glycoprotein called glomalin that binds mineral particles into stable aggregates. Dr. Christine Nichols at the USDA showed that glomalin-rich soils maintain pore spaces even when saturated because the aggregates are waterproof. Water fills the micropores inside the aggregates while air remains in the macropores between them. The root zone stays oxygenated even after heavy watering. A 2018 study measured oxygen diffusion rates in fungally active soils and found they maintained aerobic conditions at root depth even at field capacity. The same moisture level at which sterilized potting mix goes anaerobic. The fungal network builds the structure that keeps oxygen available. No pump required, no air stone, no electricity. The biology is the aerator. Now add a wicking base, the same capillary tray system covered in the paper bag and Ola episodes. Place your container in a shallow reservoir of water. The moisture wicks upward through the soil column by capillary action, keeping the root zone consistently moist without ever flooding the macropores. Water enters from below. Air stays in the large pores above. The root has simultaneous access to both, exactly like a hydroponic system, but governed by physics and biology instead of pumps and timers. System 2. Constant nutrients through the fungal network. In hydroponics, nutrients are dissolved in the reservoir at precise concentrations. The grower adjusts pH to keep minerals in ionic form. The plant absorbs them passively through root hairs. If the concentration drops, the grower adds more solution. If the pH drifts, the grower corrects it. The system requires daily monitoring because it has no self-regulation. The grower is the regulator. In a living soil, the fungal network is the regulator. Mycorrhizal hyphae extend from the root outward through the soil, mining phosphorus, zinc, copper, and other minerals from particles the root could never reach. The fungus solubilizes these minerals using organic acids, dissolving rock-bound nutrients into plant-available ionic form, the same ionic form that the hydrogrower mixes from a bottle. But here's the critical difference. The fungal network delivers nutrients on demand. When the plant needs more phosphorus, it increases sugar exudation to the fungal partner. The fungus responds by extending more hyphae toward phosphorus-rich zones. When the plant has enough, exudation decreases and the fungus redirects. This is not force feeding. This is a self-calibrating delivery system. No pH meter, no EC meter, no reservoir adjustment. The plant requests, the network delivers, the transaction is paid in sugar. Dr. Marcel van der Heijden compiled over 400 mycorrhizal studies. Mycorrhizal plants absorbed 80% more phosphorus, 60% more zinc, and 25% more nitrogen than non-mycorrhizal controls. These are the same order of magnitude as hydroponic nutrient delivery, achieved without a single purchased input. System 3. Resilience through redundancy. A hydroponic system has a single point of failure at every junction. Pump fails, roots drown or dry out. Power goes out, airstone stops, root rot begins within 24 hours. pH drifts, nutrient lockout, reservoir heats up, pathogenic bacteria colonize. Every hydroponic grower has a root rot story. Pythium, a waterborne oomycete, thrives in warm, stagnant, organic, matter-free water. Once it colonizes, the crop is often unsalvageable. A living soil has no single point of failure. If one fungal hypha is damaged, hundreds continue delivering. If one bacterial colony declines, neighbors expand. If moisture fluctuates, aggregate structure buffers the change. The system is a distributed network, not a linear pipeline, and pathogen suppression is built in. A 2016 meta-analysis in biological control reviewed 120 studies on disease-suppressive soils and found that high-diversity soils reduced root disease by 50 to 70%. The living soil defends the root. The hydroponic reservoir becomes a pathogen incubator the moment sterility breaks. Welcome to the future of the past. The biological engine is ready. Are you? The controlled environment agriculture industry is projected to reach $24 billion by 2030. Home hydroponics generates over $1.5 billion annually. That revenue comes from equipment, pumps, airstones, reservoirs, grow lights, timers, pH meters, EC meters, nutrient concentrates, pH adjusters, and replacement parts. A basic deep water culture setup runs $300 to $500. Consumables add $15 to $30 per month indefinitely. A living soil engine costs the price of compost and a container, under $10, no consumables, no electricity, no monthly cost. The industry cannot sell you a fungal network. It cannot bottle mycorrhizal delivery or package biological disease suppression. These are emergent properties of a living system. They assemble themselves when conditions are met and cost nothing to maintain. So the industry frames soil as inferior. Soil is slow. Soil is inconsistent. Soil carries disease. These claims are true for dead soil. For biologically active, fungally dominant living soil, every claim is inverted. It is fast because the network delivers continuously. It is consistent because the biology self-regulates. It is disease suppressive because the microbial community defends the root. The industry compared its $500 machine to a $5 bag of dead potting mix and declared victory. It never compared the machine to a living system because that comparison ends the sale. Here's the build. 15 minutes, under $10. Any vessel that breathes. A double-nested paper bag, a fabric grow bag, or a plastic bucket with holes drilled in the lower third of the sidewalls. Minimum 3-gallon volume. A 5-gallon bucket is ideal. Do not use bagged potting mix. It is sterilized. No biology. This is the dead soil that hydroponics legitimately outperforms. Build a living medium from 3 components. Component 1, compost. If you have been running the 14-day thermophilic protocol, use that. If not, any finished compost that smells earthy and crumbles in your hand. This carries the biological starter community. Component 2, aeration amendment. Perlite, pumice, or coarse vermiculite at roughly 30% by volume. This creates permanent macropores that keep oxygen in the root zone even when wet. Component 3, Fungal food, a handful of finely shredded hardwood mulch or aged wood chips. This is the long-term carbon source that feeds mycorrhizal fungi. They colonize the wood particles, extend their network into the compost, and connect with plant roots within 7 to 14 days. Mix all three in the container. Do not pack. The loose, airy structure is the point. It is the biological mirror of the oxygen-rich hydroponic root zone. Place the container in a shallow tray, fill with 1 to 2 inches of water. The medium wicks moisture upward by capillary action. Lower root zone stays moist, upper portion stays aerated. Refill when empty, every 1 to 3 days. That is your total maintenance. No reservoir flushing, no pH adjustment, no nutrient mixing. Pour water in a tray. To accelerate fungal colonization, add a tablespoon of native soil from any undisturbed area, a forest edge, a hedgerow, an old untilled garden. This contains wild mycorrhizal spores adapted to your conditions. If you have been running the Forever Garden protocol, take a handful of soil from under your mulch. It is already fungally dominant, already loaded with the community you need. Within 14 days, the medium is biologically active. Fungal hyphae visible as white threads. Root hairs extending into aggregate pores. Wicking base maintaining constant moisture. Macropores maintaining constant oxygen. Fungal network delivering nutrients on demand. A 2019 comparison study at the University of Vermont tested living soil beds against deep water culture for lettuce and herb production. Living soil matched DWC yields within 5%, with 0 electricity, 0 nutrient inputs, and 0 daily management. 5% yield difference, 0 operating cost, 0 labor, 0 risk of root rot. The machine is impressive, the biology is better. Hydroponics solved a real problem: how to give roots constant access to oxygen, water, and nutrients simultaneously. The solution was a machine. But the machine was never the only solution. It was the purchasable solution, the one that could be packaged, sold, upgraded, and resupplied. The biological solution, aggregate structure for oxygen, capillary wicking for moisture, fungal networks for nutrients, was always available. It has been operating in every undisturbed ecosystem for 400 million years. No electricity, no monitoring, no purchase beyond the initial build. The plant does not care whether the oxygen came from an air stone or an aggregate pore. It does not care whether the phosphorus came from a bottle or a fungal hypha. It cares that the resource arrived at the root, consistently, reliably, and on demand. The machine delivers that. The biology delivers that. One costs $500 in your time, the other costs $10 in your trust. The knowledge survives. What you do with it is yours. Subscribe to the Invincible Method and hit the bell. Share this with the hydro grower still chasing pH. Every like pushes this past the algorithm that profits from complexity. The next method drops soon, and it scales everything.